Exploring the hidden mysteries of the moon's far side. The moon, our celestial companion, has long captivated human imagination. While the near side of the moon is well studied and familiar to us, the far side remains shrouded in mystery. Over the years, scientists have made remarkable discoveries about this enigmatic region, revealing unexpected structures and hidden secrets. The massive metal mass beneath the South Pole Basin. One of the most intriguing findings on the far side of the moon is a massive metal mass buried beneath the South Pole Basin. This basin is one of the largest preserved impact craters in the solar system, spanning approximately 2,500 kilometers, 1,550 miles, in diameter. In 2019, planetary scientists using data from NASA's Gravity Recovery and Interior Laboratory, GRAIL, mission detected an unexpected mass anomaly. This structure weighs approximately 2.18 billion kilograms and extends more than 300 kilometers, 186 miles, below the lunar surface. To put this into perspective, imagine a pile of metal 5 times larger than the big island of Hawaii buried underground. That's roughly the scale of the hidden mass. One theory suggests that the mass contains metal from the asteroid that formed the South Pole Basin. When the asteroid collided with the moon around 4 billion years ago, it may have remained embedded in the lunar mantle rather than sinking into the core. Another possibility is that dense oxides concentrated during the moon's early history as its magma ocean cooled and settled. Lunar magnetic anomalies. While the near side of the moon exhibits a weak magnetic field, the far side tells a different story. Scientists have discovered localized magnetic anomalies that vary significantly from the near side. The far side of the moon has regions with stronger and weaker magnetic fields. These variations are puzzling because the moon lacks a global magnetic field like Earth's. Some researchers propose that intense impacts on the far side led to the formation of magnetic minerals. These minerals became magnetized during the impact events. Another theory suggests that the moon had a brief period of dynamo activity early in its history. During this time, a liquid iron core generated a magnetic field. However, this dynamo ceased, leaving behind localized remnants of magnetization. Lunar swirls. Lunar swirls are enigmatic bright patterns found on the far side. They stand out against the darker lunar surface. These swirls are particularly prominent in the region around the crater Compton. One intriguing theory suggests that lunar swirls result from the interaction between the moon's surface and its magnetic environment. The moon lacks a global magnetic field, but localized magnetic fields could shield certain areas from solar wind bombardment. These shielded regions accumulate less space weathering, leading to brighter surface material. Crustal thickness variations. The far side of the moon generally has a thicker crust compared to the near side. This difference is evident in gravity measurements and seismic data. The far side is dominated by rugged highland terrains, including the South Pole Basin. These highlands contribute to the thicker crust. In contrast, the near side features both highlands and large basins, such as the Imbrium and Serenitatis basins. The lunar farside highlands. The far side is predominantly covered by rugged highland terrains. These highlands are older than the large basins found on the near side. They consist of ancient crustal material and are rich in impact craters. Unlike the near side, which features dark lunar maria, large, flat plains formed by ancient lava flows, the far side has fewer maria. The highlands dominate, creating a stark contrast between the two hemispheres. The far side of the moon continues to reveal its secrets, from ancient volcanism to magnetic anomalies. As we send more missions and explore further, we'll uncover additional mysteries hidden within this enigmatic lunar realm.